So now we are coming to the troubleshooting, and we are addressing first the controls. So that's really important that you conduct all the necessary controls. And then we address the questions, what should I do if I face high background in bound fraction, no pull down of GFP fusion protein, no GFP fusion protein can be detected, or what should I do if low amount of GFP fusion protein is eluted with SDS-sample buffer? So the recommended controls. First of all, I need a positive control. A positive control, use the tag is just the tag only, so just the GFP. You have to test if the IP works, so you should get a positive signal in your SDS page and on the Western blot where you can detect the GFP with an anti-GFP antibody. Negative control is also very important. You do an immunoprecipitation without the tag. So in this case, no GFP should be in your immunoprecipitation. There is no fraction visible, or there is no line band visible in the bound fraction, either on SDS or in Western blot. The background is hopefully very, very slow. And then we have another negative control, control 2, but this control is optional. You can use the naked beads where the nanobody or the antibody is bound to and check if there is unspecific binding of proteins to the bead matrix. The protein of interest should not be bound. If other cellular proteins bound, naked beads can be used for pre-clearing. As a summary, controls are very important for the interpretation on OFP and for the troubleshooting. Now we move to our first problem, high background in bound fraction. So normally you should have, as I said, just the protein of interest, but often you see unspecific binding or high background in the bound fraction. You can see additional bands, and the reasons for that can be different. One might be that the concentration of the cell lysate is too high. Either too many cells are used or not enough buffer is used. Or cellular proteins, or also the protein of interest, is degraded or aggregated, and the aggregates binds then unspecifically to the GFP trap. What can we do to avoid such a situation? We can focus on 3 different parts of the immunoprecipitation. On cell lysis, so you have to use the right method for cell lysis. Rule of thumb is to keep everything cool to avoid protein unfolding. And you should use the right amount of cell material per immunoprecipitation. We normally say 500 micrograms total protein, or 10 up to 7 mammalian cells, or up to 10 grams of plant material. Important is to treat the sample gentle. Keep the incubation temperature at 4 degrees and short. 1 hour is normally enough, and overnight incubation is not needed. The longer you incubate your sample with the nanotraps, the higher the background will be. Due to pre-clearing with naked beads, doing pre-clearing with naked beads to remove proteins that bind unspecifically to bead matrix. And finally, you should add protease inhibitors to all buffers, not only lysis buffer, to prevent protein degradation. In washing, you could also do a couple of optimization experiments. Add detergent or increase salt to wash away unspecifically bound proteins from beads. It is important that you choose conditions where the protein of interest is still bound to beads and only unspecifically bound proteins are washed away. For washing, it is also important to use a new tube during the last washing step. If you do not switch the tube, proteins that bind unspecifically to the tube will also be found in the bound fraction. We go now to the second case, which is also very common. No pull down of your GFP fusion protein. It's not visible in the bound fraction. Also, it's in the input. The protein of interest is not precipitated and remains in flow. Again, different reasons can explain this observation. The the GFP protein is unfolded or insoluble. The GFP-Tech can't be bound. Beads are not sufficiently mixed with the cell lysate. Only a small amount of beads are used. The protein of interest is too large to enter matrix pores in case of a porous matrix like agarose is used. What can we do to avoid these kind of problems? If your protein of interest is aggregated or unfolded, it is necessary to optimize not only cell lysis, but also the expression. It's likely that your protein of interest already unfolds in the cell and not only during the cell lysis. It is important that during binding, you do a proper mixing by end-over-end rotation. Mixing by a thermomixer is often not sufficient. Always use 25 microliter of beads. If you use a smaller volume, it's difficult to pipette and to reproduce, and the amount of protein of interest can be below the SDS page detection limit. The next case we focus on is very similar to that case. The difference is that there is not only no GFP fusion protein in the bound fraction, but there is also no fusion protein in your input. So the reasons can be that the protein of interest concentration is too low because it is low abundant and below the detection limit. Or your protein of interest is insoluble because it's aggregated and found in cell debris fraction after cell lysis. What can you do to avoid this? We would recommend to increase the concentration of natively folded proteins by optimizing expression and cell lysis. Or you use more cells or a higher concentrated cell lysate to get above the detection limit. I have to add that if you cannot detect your protein in input, this is really difficult to troubleshoot, and that normally requires quite some work. The next case we would like to focus on is if the immunoprecipitation works well, but the elution with the SDS-sample buffer is not efficient. You can see on the Western blot there is a faint band, but only little of the protein of interest in the bound fraction. But you can see a very, very strong band in input. So there is not really an enrichment of the protein of interest. So the explanation is that the protein of interest is still bound to the beads after elution with the sample buffer. And to resolve this issue, it is important that you use at least 50 microliters of sample buffer. You mix properly with the pipette before and after boiling.